Okay, so for this part of the notes, we're going to look at the process of algebraic long division. Before we actually look at the examples in the kind of printed notes, we're going to try a bit of rough work first and try out some other examples. It's really important before we do algebraic long division that we definitely understand the standard division, how it all fits together. So to begin, we're going to look at a nice simple example like, for instance, 15 divided by 7. This really isn't patronising, it is worth understanding this. So if you are going to divide 7 into 15, you know that it goes in twice with remainder 1. That's a way of writing division that we don't really do very often anymore. These days, if you were going to do 15 divided by 7, you would usually write your answer instead as 2 and 1/7. Okay? So if you want to divide 7 into 15, it goes in twice with 1 left over, but that 1 is really 1/7. This divisor, the thing you're dividing by, still appears over here. The only slight confusion here is the way we would standardly write a mixed number like this. Standardly is not a word, but you know what I mean. The way we'd usually write this is 2 and 1/7. It's perhaps a clearer way of writing it if we write it like this. So similarly, in a second, we're going to be dividing algebraic expressions, but other pieces of algebra will get a quotient, we'll get the amount of times it goes in, and we'll also get a remainder. And this method here will come back as the way we write it. So let me actually try the process of long division. And we're going to do an example here, and we're going to interpret our answer at the end and write it in this format here. Well, this one here up. So let's try this example here. Let's try working out what the answer is to x cubed minus 4x squared plus 2x plus 5, and let's divide that by x minus 2. Okay, so we're going to try and work out how many times x minus 2 goes into this. That'll give us this number here, and we're also going to get a remainder, which we will write over the thing we're dividing by. Here we were dividing by 7, here we were dividing by x minus 2. So we'll get the number of times it goes in, which will be a piece of algebra, and we'll also get the number of times it goes in over this divisor here. So let's see that in action. So we write it like this, x minus 2 dividing into x cubed minus 4x squared plus 2x plus 5. And here we go. So there's going to be a lot of me switching here between the pen and the pointer. So the first thing I do is I look at this and see how many times does x go into x cubed. And I know that it goes in x squared times. The reason I know that's the answer is because x squared times x does give me x cubed. Okay? So how many times does x go into x cubed? It goes in x squared times. So now I'm going to times x squared by this whole thing here. So by definition I know I'm definitely going to get x cubed again. So I'm going to times this by this. And I'm going to get x cubed minus 2x squared. I'll draw a little line. So x went into this x squared times, and I timesed x squared by this expression here. So there are a few points during a long division where you can pause for a second. This is one of them. So we're now going to do a takeaway. And we're going to do x cubed take away x cubed, which gives us nothing. We're then going to do minus 4x squared take away minus 2x squared. That's going to give us minus 2x squared. And then we bring this next term down. Okay. Now this is the bit where it begins to repeat. Everything we've just done we're now going to do, but we're going to be dividing x minus 2 into this thing down here. So let's first of all put x into minus 2x squared. And it's going to go minus 2x times. Okay. And we're now going to multiply this by this, and write it underneath and do a takeaway on all of that. Now, minus 2x times x has to give us minus 2x squared again. Minus 2x times minus 2 is going to give me plus 4x. And again, I can draw my line there before I do my takeaway. So, I am now going to do that takeaway. Minus 2x squared take away minus 2x squared is going to disappear. You're taking the same thing away from itself. And this minus being taken away becomes a plus. Either way, you get a 0. I'm then going to do 2x take away 4x. That's going to give me minus 2x. And I'm going to bring down that plus 5. So now I'm going to say how many times does x go into minus 2x? And the answer is minus 2. I'm then going to times minus 2 by this expression here, and I will get minus 2x plus 4. And I'm going to draw my line there. And you can sort of see at this point you sort of run out of things you could get here. There can't be any more divisions going on, and we'll see that that's the case down here, because when I do this takeaway, minus 2x, take away minus 2x goes away, and 5 take away 4 is going to give me 1. In the same way as there's nothing left that I could really write here, x is not going to go into 1, so I'm complete here. I've finished this division. Now I just need to interpret my answer and write it in this format that we spoke about up here. So I was trying to work out how many times x minus 2 went into this expression here, and this is my answer. This is how many times it goes in, but there is a bit left over, there is a remainder. So let's write it in this format here. So when I do this division here, I get the answer, x squared minus 2x minus 2. I'm just going to write that in brackets to sort of keep it together. And I also then get a remainder of 1, which is a legitimate way of writing it, but it's not very useful for most of the things we need it for. So we keep on going, and we say that's the same thing as x squared minus 2x minus 2 plus, and my remainder goes over what I'm dividing by. I'm dividing by x minus 2, and that gives me this as my answer. Okay, so when I divide x minus 2 into x cubed minus 4x squared plus 2x plus 5, I get this and this remainder. And this is what it looks like when I write it as a fraction. This is the way you really should be writing your answers. So let's now look at another example, another long division. So let me get a new slide. So the next example we're going to try is this one here. We're going to try 2x cubed minus 5x squared minus x plus 6 divided by, brackets help to make this a bit clearer, divided by x plus 1. To do the algebraic long division, I'm actually going to write it in that format that we're used to. So I'm going to write it as x plus 1 dividing into 2x cubed minus 5x squared minus x plus 6. That's more like a 3 now. So first things first, how many times does x go into 2x cubed? It goes in 2x squared times. So then I'm going to times 2x squared by this whole expression here to get 2x cubed again plus 2x squared. I draw my line. Now I do my takeaway. 2x cubed take away 2x cubed gives me nothing. Minus 5x squared take away positive 2x squared gives me minus 7x squared. And I bring down that minus x. I'm now going to divide x into minus 7x squared. That gives me minus 7x. I then times minus 7x by this whole thing here, and that will give me minus 7x squared minus 7x. Draw my line. I now do a takeaway. Minus 7x squared take away minus 7x squared gives me nothing. Minus x take away minus 7x will give me plus 6x. Bring down my 6 plus 6. At this point you can maybe see what's going to happen because you can see x plus 1 goes into the whole thing, but I'm going to keep doing the whole method as I've done it up to now. So x goes into 6x 6 times. I then times 6 by x plus 1, and I'm going to get 6x plus 6. Draw my line. I do my takeaway. 6x take away 6x is nothing. But in this case as well, we have 6 take away 6 is also nothing. So I end up with a remainder of 0. So this actually tells me that x plus 1 goes into this exactly. The number of times x plus 1 goes into this is this. So when I go to write this out, I'm going to write my final answer as 2x cubed minus 5x squared minus x plus 6, all divided by, I'm going to sneeze, what a professional. And when I divide by x plus 1, we've seen that the answer is 2x squared minus 7x plus 6, remainder 0, which really doesn't need to be written down. If you really want to force the point, you could, instead of writing remainder 0, wrote plus 0 over x plus 1. But again, that's nothing. So here we've got an exact answer. Later on you see that this way of writing things is particularly nice for factorising things, because if you times through by this, what you've shown is that 2x cubed minus 5x squared minus x plus 6 is equal to 2x squared minus 7x, that should be a minus, plus 6 times by x plus 1. So at this point you've factorised this initial expression into this, and in fact that factorises even further. So this is going to be our method later on for factorising cubics. So now we'll do the actual examples in the notes. We'll do them from scratch on here because it's very hard to sort of explain the solution that's already written out, but you can compare what I write now to what I'd already written out and scanned. So the first example is dividing x plus 2 into x cubed plus 6x squared plus 11x plus 6. So, first things first, x into x cubed goes x squared timesing x squared by this thing here gives me x cubed plus 2x squared. Draw my line. X cubed take away x cubed is nothing. 6x squared take away 2x squared is going to give me 4x squared. Bring down my 11x. I then do x into 4x squared is going to give me plus 4x. 4x times x plus 2 is going to give me 4x squared plus 8x. I'm going to do my takeaway. 4x squared take away 4x squared is nothing. 11x take away 8x is 3x. Bring down the plus 6. And now I'm going to do x into 3x is going to give me plus 3. And then times 3 by this thing here, you get 3x plus 6. Do my takeaway, and I'm going to get 0. So it turns out that x plus 2 goes into x cubed plus 6x squared plus 11x plus 6 exactly. So my final answer will just be to write that the answer to x cubed plus 6x squared plus 11x plus 6 all divided by x plus 2 is x squared plus 4x plus 3 with nothing on the end. You're not going to write either remainder 0, you're not going to write plus 0 over this because they're both 0 anyway, contribute nothing to it. The next example asks us to work out what we get when we do 4x cubed minus 7x squared plus 1 all divided by x plus 1. Now we have to be very careful in this one here because if we look at this top line here, there's an x cubed term, an x squared term, and we're missing an x term. There's a 0x term in there plus 1. Because the way our method works, we're going to fill out all of those components. There must be an x cubed all the way down to a number term. If that means you write it in with a 0, then you have to do that. So I'm going to write x plus 1 dividing into 4x cubed minus 7x squared plus 0x plus 1. If you're feeling very contrary, you can write that as minus 0x, obviously it doesn't make any difference. And now we begin to do the whole method. Okay, this 0 won't really change things very much at all. So x into 4x cubed goes 4x squared times. 4x squared times this x plus 1 gives me 4x cubed plus 4x squared. I do my takeaway. 4x cubed take away 4x cubed is nothing. Minus 7x squared take away 4x squared is going to give me minus 11x squared. I bring down my plus 0x. And now I divide x into this thing here. I'm going to get minus 11x. Minus 11x times this expression here is going to give me minus 11x squared minus 11x. And I'll do my takeaway. Minus 11x squared take away minus 11x squared is nothing. 0x take away minus 11x is going to give me 11x. Bring down my 1. I get my plus 1 there. I'm now going to do x into 11x, and that gives me plus 11. 11 times this thing here is going to give me 11x plus 11. I do my takeaway. 11x take away 11x is nothing. 1 take away 11 is minus 10. Well, you can't go any further with this because x doesn't go into minus 10. So now I write down my final answer. And my answer is that when you do, in fact, I'll just squeeze up here. When you do that division up there, you get this thing here. That's how many times x plus 1 goes into this top expression. So you get an answer of 4x squared minus 11x plus 11. But you've got a remainder as well. So I've also got this extra term. The remainder is minus 10 over x plus 1. So my remainder is always, well, a remainder is minus 10, but I write that algebraically as minus 10 divided by what I was originally dividing by. This just looks a little bit clumsy, so you wouldn't usually add on a negative, you'd usually just say that's a takeaway. So I would probably replace that with minus 10 over x plus 1. So my full answer would be 4x squared minus 11x plus 11, take away 10 over x plus 1. That would be the full answer to that question there. Okay, so here are the notes that you have, and these are the two examples we've just done. And here is an example of the fallibility of even the greatest of us. I noticed that when I've done this example here, I've actually made a mistake. I haven't got the same answer that I got on the previous page. So if you look at what I've done wrong here, let's just try and find my mistake here. We can almost pretend this is in the exam and we're checking through our work. So if you look at what I've done here, I have done x into 4x cubed is 4x squared. I'm correct on that bit there. And then I've times 4x squared by x plus 1, which gives me 4x cubed, but it doesn't give me minus 4x squared. So that really there should have been a plus. And of course, when I have a plus there, I'm going to get a different answer there, and the whole thing sort of falls apart. You'll be pleased to know that the scanned copy of these notes I have corrected, so we need never speak of this terrible, terrible mistake ever again. Okay, so let's now move down and look at this next example, which is new. And here we are told that you need to find the remainder when this thing here is divided by 2x minus 5. So we're going to divide 2x minus 5 into this thing here and see what's left over. Now the next bit should make you suspicious already of what the answer should be. It says hence factorise completely and solve this cubic equation. This is actually an example which is going to come up much later on and be a real kind of classic example and one of the key things you should expect to come up in your C1 exam. But for now, we can pretty much understand this just based on what we know about division. So we'll come to this hence in a second and see why this first part's so useful. So you're going to divide 2x minus 5 into this thing here. So 2x minus 5 dividing into this thing here. 2x into 2x cubed goes x squared times x squared by 2x minus 5, and you get this thing here, 2x cubed minus 5x squared. Do the takeaway, nothing there. Minus 9x squared, take away minus 5x squared, gives you minus 4x squared. 2x into minus 4x squared is minus 2x. Minus 2x times this thing here is minus 4x squared plus 10x. I've lost all confidence in myself now. 12x take away 10x is 2x. Bring down the minus 5. I'm leaving out that arrow. That's not really things that most people actually do. I only did it for the sake of making the working clearer. 2x into 2x goes once. 1 times 2x minus 5 is 2x minus 5. You do the takeaway and you've got the 0. The 0 you know you should get. Okay? And the reason you should know you should get that is because this tells me that this is a factor. You're being told to factorise completely, and this first part of the question is the clue. 2x minus 5 is a factor. It has no remainder. So I can write, and I'll just do an in-between step here, I can write down that 2x cubed minus 9x squared plus 12x minus 5 divided by 2x minus 5 equals x squared minus 2x plus 1 with no remainder on the end, no extra fraction going on. So because the division has told me this, I can say something about 2x cubed minus 9x squared plus 12x minus 5, which is something I am trying to say something about. So this divided by this gives me this. So multiply this across to the other side, and you have this statement here. This is equal to 2x minus 5 times this. That's an alternative way of just always writing out your answer to this. If you get a remainder of 0, then this is equal to these two things multiplied together. So in my goal to completely factorise this, I've written that this is equal to 2x minus 5 times this bracket here. This bracket I can factorise as well, and I get x minus 1 all squared. And once something's completely factorised, it's very easy to solve. So rather than saying this thing is equal to 0, I can now say, well, this thing is equal to 0. When is this happening? Well, it's going to happen when x is 5 over 2 or x is 1. Now, cubics can have 1, 2 or 3 solutions. In this case you've got 2, which means that it cuts in one place and touches in the other. So it's not asked for, but let's draw a little sketch. So it's a positive shaped cubic. It's doing kind of that shape there. So where's it going to cross? It's going to cross at 5 over 2. Oh, actually, sorry, I'll make that the 1 and I'll make this the 5 over 2. Because 5 over 2 is 2.5, it's further along. Now, looking at this here, I'm going to draw my cubic. At one place it's going to cut, and one place it's going to touch. So I'm going to draw it like this. Oh, hang on. I'm going to draw it like this, touching, and then going through like that. Now, the previous way I drew this was terrible, so you might have noticed the jump in the video there as I cut back in. This is not much better, but this is the shape of that cubic. And one thing to notice is there was another alternative here. I could have done, that. Okay, so you did have to make a decision here about whether it was cutting here and touching here, or touching here and cutting here. If you look back at the original statement here, you can see that this is the bit where it just touches. This is really, I think, a merging of two roots. It's almost as if this was two separate things. It would have been just cutting at x minus 1.5 and just cutting at x minus 0.5, just either side of the minus 1, and they've merged together. That repeated root is where it touches twice. Okay, so if it's just a little point where it just touches and then goes back down again. This is the kind of simple one, looks exactly like it always looks, that's where it cuts. This is the one that looks a bit different, it's like a repeated root, that's where the interesting thing must be happening. So the red graph is the graph of this thing here. Not asked for, but interesting to think about.